Swayam Prabha. Digital India. Educated India.
Namaskaram. I am Dr. Gunapriya Raghunath, Professor and HOD of Anatomy, Savitha Medical College and Hospital, Chennai. In today's session, we are going to study about duodenum. So, duodenum is the most proximal part of the small intestine, what you can make out here. So, in this cadaveric specimen, this is the duodenum. The duodenum is receiving the acidic contents from the stomach, and from the duodenum, the partially digested food material is passed on further into the jejunum, the next part of the small intestine. So, in today's session, we will be studying completely about the anatomy of duodenum. What are the objectives of this session? After going through this entire session, the student should be able to describe the extent, shape, location, parts and relations, interior, suspensory ligament, duodenal recesses, blood supply, lymphatic drainage, innervation and clinical anatomy of duodenum. These are the objectives that should be met at the end of this session. Now, as in any other session, we will go to a clinical problem now. A young male, too busy and irregular in his food habits, frequently complained of upper abdominal pain to the right of epigastrium. The pain was burning in nature and was relieved after taking food. He was treated for peptic ulcer by a gastroenterologist and his symptoms were relieved to a great extent. Which is the organ involved in this case? What are its parts? How is it pulled up and kept in position? What are its features internally? What are the structures opening into it? How is the occurrence of peptic ulcer prevented naturally? How is a duodenal cap formed in a barium meal image? So, we have gone through a clinical case here and there are a set of questions following. So, after going through this entire session today, we will analyze this case, resolve it and answer all these questions. So, let us move on to the core topic today. Duodenum. Duodenum is derived from the Greek word dodekadaktylos. Dodekadaktylos means do means 2, deca means 10, dactylos means fingers. So, dodekadaktylos Greek word was coined way back in 300 BC by Herophilus, which means it is equal to the total breadth of 12 fingers. So, if you take your 10 fingers of your hand, add 2 more fingers here and you count the breadth or the width of all the 12 fingers including the other 2, then that is equal to the length of the duodenum, which is about 25 centimeters or 10 inches. So, dodekadaktylos means the length of the duodenum is equal to total breadth of 12 fingers. Duodenum is a proximal, shortest, dilated and fixed part of small intestine. So, you can make out here in the picture, it is having a C-shaped cave and in the concavity is fitting the head of the pancreas. The C-shaped duodenum does not have any mesenteric fold attached to it. Coming to the parts of duodenum, measuring 25 centimeters in length, the duodenum is made up of 4 parts, totally measuring 25 centimeters or 10 inches. The first part is horizontal, measuring 5 centimeters, lies at the level of first lumbar vertebra. It turns down, makes a bend which is known as a superior duodenal flexure and runs down up to the level of L3 vertebra. So, this vertical part is known as the second part and this measures around 7.5 centimeters in length. Pause. Okay. In the slide model solreen. So, duodenum is broken up into 4 parts measuring totally 25 centimeters or 10 inches. The first part is the horizontal part measuring 5 centimeters, lies at the level of L1 vertebra. It then makes a bend downwards known as a superior duodenal flexure to continue further as the second part of the duodenum. The second part of the duodenum goes up to the L3 vertebra. It is vertical, measures 7.5 centimeters in length, extending from L1 vertebra to L3 vertebra. The third part is the horizontal part which measures 10 centimeters in length, lies at the level of L3 vertebra, extends from the inferior duodenal flexure. This bend is formed between the second part and the third part, which is the inferior duodenal flexure, from where the third part of the duodenum commences and goes over to the junction between the L2 L3 vertebra, where it continues further as a fourth part of duodenum. The fourth part is the ascending part of the duodenum, which measures 2.5 centimeters in length, and it further continues as the jejunum. So, this is about the parts of the duodenum and each one's extent and dimensions. Moving over to extent, shape and location. Duodenum extends from the pylorus of the stomach to the duodenojejunal flexure, totally measuring 25 centimeters in length. Begins from the pylorus at the transpyloric plane, 2.5 centimeters to the right of the midline, and ends at the duodenojejunal flexure, 2.5 centimeters to the left of median plane, a little below the transpyloric plane. The duodenum is a C-shaped small intestinal loop having a concavity which encloses the head of the pancreas. The complete duodenum lies opposite the levels of L1, L2 and L3 vertebra. This is about the extent, shape and location of the duodenum. Moving on to each individual part of the duodenum. First part of duodenum taking into consideration now. Coming to general features of the first part of the duodenum develops from foregut. The gut is giving rise to the various parts of the gastrointestinal system. There are three subdivisions of the gut embryologically, which means the foregut, midgut and hindgut. The foregut gives rise to the esophagus, stomach and the first part of the duodenum and the upper part of the second part of the duodenum. So, here the first part of the duodenum is developing from the foregut. It is partially retroperitoneal, it is freely mobile and distensible. There are no circular mucosal folds in the proximal part. I am highlighting this feature because we expect the entire small intestine to have a large number of circular mucosal folds, which will increase the surface area available for absorption. But in the case of first part of duodenum, since it is a continuation of the stomach, it shares some common features of stomach and some common features of small intestine as well. So, there are no circular mucosal folds in the first part of the duodenum. Later, they appear and keep increasing in number. There is a feature known as duodenal cap that is formed in a barium meal image, which is a very normal phenomenon. We will come back to it later. Duodenum also, first part of the duodenum also is one of the favorite sites for formation of peptic ulcers or duodenal ulcers. The first part of the duodenum is supplied by branches of celiac trunk. Celiac trunk is the artery of the foregut. Since the first part is developing from foregut, it is supplied by the artery of the foregut, which is the celiac trunk. Coming to the course of the first part, it begins as the pylorus. It runs upwards, backwards and laterally to the right side of the vertebral column, reaches the neck of the gallbladder and then bends down to make a bend of flexure known as superior duodenal flexure, after which it is continuous with the second part. Going on to the relations of the first part, coming to anterior relations, anteriorly it is related to quadrate lobe of liver, gallbladder, and posteriorly it is related to portal vein. You can make out the portal vein there. Posteriorly is related to the portal vein, the gastroduodenal artery, then the bile duct is there, common bile duct is there, gastroduodenal artery and the portal vein is also there. Superiorly it is related to the epiploic foramen or foramen of Winslow, and inferiorly it is related to head and neck of pancreas. Going through the relations once again, anteriorly it is related to quadrate lobe of liver, gallbladder, posteriorly related to portal vein, gastroduodenal artery and the bile duct, common bile duct. Superiorly it is related to epiploic foramen, inferiorly it is related to the head and neck of pancreas. So, having finished with the first part, we are now moving on to the second part of the duodenum. It extends from the superior duodenal flexure, it passes down to L3 vertebra and turns to the left, forming the inferior duodenal flexure and becomes continuous with the third part of the duodenum. Coming to the features, the upper half of the second part up to the opening of the major duodenal papilla develops from the foregut. The remaining half, the lower half, will be developing from, Coming to the features, the upper half of the second part of the duodenum is developing from the foregut up to the opening of major duodenal papilla. The remaining part of the second part of the duodenum develops from the midgut. It lies behind the transverse colon The bile duct, the major and minor pancreatic ducts will be opening into the interior of the second part of the duodenum. This is the only part of the intestine which is supplied by two rows of vasa arising from the anterior and posterior pancreatico-duodenal arcades. So, these are the special features of second part of duodenum. Coming to the relations of the second part of the duodenum, anteriorly it is related to gallbladder, the right lobe of liver, the transverse colon and the transverse mesocolon. Posteriorly it is related to the right kidney, the right renal vessels and the right edge of inferior vena cava. Medially, the concavity is occupying the head of the pancreas. Laterally, it is related to the ascending colon, the superior flexure or the hepatic flexure of the colon and right lobe of liver. So, to go through the relations once again, anterior relations will be formed by the gallbladder, the right lobe of liver, the transverse colon and the transverse mesocolon. Posteriorly, it is related to the right kidney, the right renal vessels and the right edge of IVC. Medially, the concavity will be occupying the head of the pancreas. Laterally, it is related to ascending colon, hepatic flexure of colon or the superior flexure of colon and the right lobe of liver. Having done with the second part of the duodenum, we are now moving on to the third part of the duodenum. The third part of the duodenum, as you see in the picture, it is horizontal. It is horizontal, it is the longest part of the duodenum measuring 10 centimeters. It lies at the level of third lumbar vertebra in front of inferior vena cava and bends upwards and becomes continuous with the fourth part. Coming to the relations, anteriorly it is related to superior mesenteric vessels, the root of mesentery and coils of jejunum. Posteriorly it is related to the right psoas major, the right ureter, then you have the right gonadal vessels, inferior vena cava, abdominal aorta and inferior mesenteric artery. Superiorly it will be related to the head of the pancreas with the uncinate process. Inferiorly it is related to coils of jejunum. To go through the relations of the third part of duodenum, once again, anteriorly it is related to superior mesenteric vessels, the root of mesentery and the coils of jejunum. Posteriorly it is related to right psoas major, right ureter, right renal vessels, inferior vena cava, abdominal aorta and inferior mesenteric artery. Superiorly, it is having relationship with the head of the pancreas along with the uncinate process. Inferiorly, it is related to coils of jejunum. Having studied about the third part of duodenum, now we move on to the last part, which is the fourth part of the duodenum. The fourth part of the duodenum runs upwards to the left of the abdominal aorta up to the level of L2 vertebra to become continuous with the jejunum at a flexion known as duodenojejunal flexure. Coming to the relations, anteriorly the fourth part is related to transverse colon and transverse mesocolon. Posteriorly it is related to left sympathetic chain, inferior mesenteric vein, left psoas major, left gonadal vessels. Superiorly it is related to body of pancreas, to the left it is related to left kidney and left ureter, to the right it is related to upper part of the root of mesentery. To go through the relations of fourth part once again, anteriorly it is related to transverse colon and transverse mesocolon. Posteriorly it is related to left sympathetic chain, inferior mesenteric vein, left psoas major, left gonadal vessels. Superiorly it is related to body of pancreas. To the left it is related to left kidney and left ureter. To the right it is related to upper part of the root of mesentery. Having finished with the fourth part of the duodenum, now we move on to the interior. So, external features have been done with. Now we move on to the interior. When you open up a specimen of the duodenum, cut it inside and see the interior, what are you going to observe? We will be observing the following structures in the interior of the duodenum. Valves of Kerckring are the circular folds. These valves of Kerckring are circular mucosal folds which serve to increase the surface area of the small intestine available for absorption. So, to facilitate or enhance the absorption, you need to increase the surface area. One of the factors which increase the surface area available for absorption is valves of Kerckring. These valves of Kerckring are characteristically absent in the first part of the duodenum because first part of duodenum bears similar features like the stomach. So, they start appearing from the second part of the duodenum and gradually keep increasing in number as we keep moving distally forward. The major duodenal papilla appears as a conical projection on the posteromedial wall of the second part of the duodenum at a site 8 to 10 centimeters distal to the pyloric orifice. On the summit of this papilla, you find the opening of the common hepatopancreatic duct. This common hepatopancreatic duct is formed by the union of the bile duct and the major pancreatic duct. Then there is another papilla known as minor duodenal papilla, which is another small conical projection which lies at a distance of 6 to 8 centimeters distal to the pylorus. The accessory pancreatic duct opens on the summit of the minor duodenal papilla. Plica semicircularis is a semicircular form of mucosal arch seen over the major duodenal papilla like the hood of a monk. Hence, it is known as monk's hood. So, what you see here, that is known as the monk's hood. Looking like a monk's hood, it is a mucosal arch seen over the upper part of the major duodenal papilla. Plica longitudinalis is a vertical tortuous mucosal fold running downwards from the major duodenal papilla. So, these are the structures or features that you will see in the interior of the duodenum: valves of Kerckring, major duodenal papilla, minor duodenal papilla, plica semicircularis and plica longitudinalis. Now, there is another important ligament which holds the duodenojejunal flexure in position normally, which is known as suspensory ligament of Treitz. So, that is the duodenum. You find the right crus of the diaphragm, the aorta is there, and you have the yellow color one is the suspensory ligament of Treitz. Suspensory ligament of Treitz is a fibromuscular band which suspends the duodenojejunal flexure from the right crus of diaphragm. It is attached above to the right crus of diaphragm and below to the posterior surface of duodenojejunal flexure. It is having different types of fibers along its entire end. The upper part is made up of striatal muscle fibers, the middle part is made up of elastic fibers, and the lower part is made up of smooth muscle fibers. Now, what is the function of suspensory ligament of Treitz? The suspensory ligament fixes the duodenojejunal flexure and prevents it from being pulled down by the weight of the rest of the intestines. So, this also contributes to the normal C-shaped structure of the duodenum. If the suspensory ligament is very short, then the duodenum can become O-shaped. If it is very long, it can be too loose and the duodenum can become a reverse J-shaped. If it is normal, then the duodenum acquires its normal C-shape. So, that is about the suspensory ligament, the structure and the function of suspensory ligament of Treitz. Moving on to small recesses or hidden spaces seen in relation to duodenum. These are known as duodenal recesses. Duodenal recess is a small pocket-like pouch of peritoneum. So, whenever there are small spaces or pockets of peritoneal pouches in the abdominal cavity, the small intestines, which are very freely moving, freely movable and mobile and wandering everywhere in the abdominal cavity, can peep into these small pouches of peritoneum and result in hernia within the abdominal cavity known as internal hernia. So, internal hernia is one which occurs into small narrow spaces or openings seen within the abdominal cavity. So, loops of small intestine may herniate into these recesses, resulting in internal hernia, and if those openings or spaces are very narrow, it can even strangulate these small intestine and can result in a strangulated hernia. So, we find some recesses named as superior duodenal recess, inferior duodenal recess, paraduodenal recess and retroduodenal recess. The retroduodenal recess is supposed to be the largest one. The important clinical significance of knowing these recesses will be that these favor the occurrence or the chance of formation of internal hernia, wherein a small part of the small intestine can enter into these small recesses or peritoneal pouches and get locked there and can form internal hernia and get strangulated as well. Coming to the arterial supply. A whole list of arteries supply the duodenum, the superior pancreatico-duodenal artery, which is a branch of the gastroduodenal artery, which in turn is a branch of the hepatic artery, and that in turn is a branch of the celiac trunk. The inferior pancreatico-duodenal artery, which is a branch of the superior mesenteric artery. These two are the major arteries supplying the duodenum. These two arteries will form arcades, an arch of arteries known as anterior and posterior pancreatico-duodenal arcades. In addition to these two pancreatico-duodenal arteries, you also have supraduodenal artery of Wilkie. Supraduodenal artery of Wilkie also supplies the duodenum, and especially the first part, it is also a branch from the gastroduodenal artery. In addition to this, you also have retroduodenal branches arising from the gastroduodenal artery and direct branches arising from the hepatic artery and right gastroepiploic artery. So, the most important arteries to be kept in mind will be the arterial arcades formed by superior pancreatico-duodenal artery and inferior pancreatico-duodenal artery. These two form arches in the form of anterior and posterior pancreatico-duodenal arcades. Coming to venous drainage, the veins will be draining into, like any other abdominal structure, will be draining into splenic veins, superior mesenteric veins, and finally into portal veins. The lymphatics will be draining into pancreatico-duodenal nodes along the inner curvature of the duodenum. From there into celiac nodes, from there into superior mesenteric nodes, and finally into the lymphatic sac known as cisterna chyli, from where the thoracic duct arises. Innervation, nerve supply. So, it is an organ which is not under our control. So, obviously, it is supplied by the autonomic nervous system. The sympathetic nerves are arising from the T6 to T9 spinal segments of spinal cord. The parasympathetic nerves are derived from the vagus. These nerve fibers will run along the arteries and reach the duodenum. Clinical anatomy. Duodenal ulcer is said to be more common when compared to gastric ulcer. An ulcer is a necrotic change in the mucous membrane due to reaction to acidic contents. We know that duodenum does not synthesize any acid actually, but how is it to react to the acid? The first part of the duodenum receives acidic contents from the stomach, and that favors the formation of ulcers more in the case of duodenum. Duodenal ulcers can be treated by medicines using drugs. It can be treated surgically also if it is worse, by a surgery known as truncal vagotomy with gastrojejunostomy. Truncal vagotomy is a procedure where the vagus nerve, a part of it is severed, because we know that vagus nerve facilitates the acid synthesis or acid secretion. So, to inhibit the acid secretion, we need to cut out the contribution given by the vagus nerve. Hence, a part of the vagus nerve is severed, and that is known as truncal vagotomy. And there is a shunting procedure done so that the duodenum is bypassed. Directly food contents from the stomach will be entering into jejunum, and that shunting surgery is known as gastrojejunostomy. Duodenal cap is a normal phenomenon which is formed for all of us if we undergo a barium meal series study. So, when a person is subjected to barium meal series investigation, the first part of the duodenum appears as a triangular shadow, what you see here. This triangular shadow known as duodenal cap is a normal phenomenon which would be seen for all of us if we undergo barium meal series study or investigation. This duodenal cap is formed by two factors. Number one is the absence of circular mucosal folds in the first part of the duodenum. Number two will be the pyloric part of the stomach is protruding or projecting into the first part of the duodenum. So, these two factors favor the formation of a duodenal cap, which is still said to be a normal phenomenon for all of us. Duodenal diverticula are outpouches from the main cavity of the duodenum. So, the cavity of the duodenum has an extension outside, and that is duodenal diverticulum. Duodenal obstruction can occur due to a congenital anomaly of the pancreas known as annular pancreas, where the two embryological buds of the pancreas go around the second part of the duodenum, thereby obstructing the second part of the duodenum. The investigative procedures which can be used to diagnose clinical conditions of duodenum will be ultrasound, endoscopy, and CT scan. And finally, another procedure known as endoscopic cholangiopancreatography is one which is done through an endoscope, but to visualize the biliary tree. You can visualize the common bile duct, the pancreatic ducts, you can go up to the hepatic ducts. So, this procedure is done through the major duodenal papilla by passing a probe through the endoscope, entering through the major duodenal papilla, and from there advance the catheter or the probe into the major pancreatic duct, minor pancreatic duct, and common bile duct. So, that procedure is known as endoscopic cholangiopancreatography. Last is not very common, cancer duodenum. Like any other organ, duodenum can also develop a malignancy in it, and this is known as cancer duodenum or malignancy of duodenum. So, that is about the clinical anatomy of duodenum. Now, let us go back to the case that we saw in the beginning. A young male, too busy and irregular in his food habits, frequently complained of upper abdominal pain to the right of epigastrium. The pain was burning in nature and was relieved after taking food. He was treated for peptic ulcer by a gastroenterologist, and his symptoms were relieved to a great extent. So, there are some hidden clues here. Relieved after taking food. when an abdominal pain is relieved, when a burning type of abdominal pain is relieved after taking food, it is more in favor of duodenal ulcer. If a pain is getting aggravated after taking food, it is more in favor of gastric ulcer. So, which organ is involved in this case? It is duodenum. What are the parts of duodenum? First part, second part, third part and fourth part. How is it pulled up and kept in position? Normally by the suspensory ligament of Treats, which connects the duodenal flexure to the right crus of diaphragm. What are its features internally? Internally we saw the valves of Kerckring, we saw the major duodenal papilla, minor duodenal papilla, plica semicircularis and plica longitudinalis. What are the structures opening into it? The openings of major duodenal papilla and the minor duodenal papilla. How is the occurrence of peptic ulcer prevented naturally? That's a nice question to answer. Peptic ulcers are formed by increased acid secretion and irregular food habits and stress. There are so many factors leading to the formation of peptic ulcers. But naturally, there is a God-given mechanism to prevent the formation of peptic ulcers. The duodenum, which always receives acidic contents from the stomach, naturally itself has a mechanism to prevent the formation of duodenal ulcers. This is by the secretion given by the submucosal glands of Brunner seen in the submucosa of the duodenum. So, in histology we would have studied that the submucosa of the duodenum contains Brunner's glands. So, Brunner's glands, the most important chemical synthesized is bicarbonate ions. So, bicarbonate ions are alkaline. So, definitely the acidic contents received by the duodenum will be neutralized by these bicarbonate ions synthesized by the Brunner's glands in the duodenum. How is the duodenal cap formed in a barium meal image? We saw this earlier. The duodenal cap is formed by two factors. Number one is the absence of circular mucosal folds in the first part of the duodenum. Number two, the pyloric part of the stomach protrudes or projects into the first part of the duodenum. These two factors normally favor the formation of duodenal cap. So, this duodenal cap is seen in a barium meal image, not otherwise. So, we have gone through the entire clinical case. After the session, we have analyzed it and we have resolved the case and we have answered all the questions. Hope this session was interesting. Looking forward to see you all again in another session like this. Thank you.